Okay, so with the velocity time graph, right, there's a couple of things, important things you need to remember. The first rule is that the acceleration can be worked out if you determine the gradient. Okay, so the acceleration is the gradient of the line at any particular time, right? Now in this case, they want you to work out the acceleration when the time is 10. So time is 10, is roughly there, isn't it? That's when t is 10. And we're going to be there on the line around there. Okay, so if we can work out the gradient at that particular point, then we've got the acceleration. But the good thing is the gradient at that point is the same as the gradient of this whole line, yeah? Because it's a straight line, so the gradient is going to be the same all the way along there. So if we can work out the gradient of that line, we've got then the acceleration. And the acceleration will be the same along all that line there. And of course when t equals 10 around here. So to get the gradient, of course, remember we draw a triangle, okay, on this line here. So we can draw a triangle, and we draw this triangle here, and it's quite simply the gradient will be the rise divided by the step, won't it? Okay, so the rise in this case, okay, this vertical distance here will simply be the change in velocity, won't it? That's how we see it. Change in velocity, and the step, okay, the horizontal component, of course, is the change in time. Okay, so to get the gradient, then you do the rise divided by step, so it'll be the change in velocity divided by the time. So in this case, change in velocity, well, it goes from 5 to 20. Okay, so 20 take away 5, and the time will be that component there, 30 seconds. All right, so you type that into your calculator, you get 15 over 30, which is 0.5 meters per second squared. Okay, so that's the acceleration when t equals 10 seconds. So remember, the acceleration is the same all the way along here, so of course it's going to be the case when t equals 10. Now we also need to work out the acceleration when t is 420. Now time 420 is about here, isn't it? Okay, roughly there. And if we look up the line there, okay, we just need to work out what the gradient is, okay, of this whole line going across, because it's going to be the same, isn't it? Okay, straight line. But what's great about this is that we've got a flat line, okay? So when we've got a flat line, of course, the gradient is 0, isn't it? Gradient is 0, because there's no slope. It's completely flat. You're not going to slide down this. So gradient is 0, which means the acceleration is also going to be 0. 0 meters per second squared when t equals 420 seconds.